So we will start. Anurag, you are able to see my screen?
Yes, I can able to see.
What are you able to see? Can you confirm?
Find my file a case study in the model Android.
What we'll do is we will go through an app development process in few days, where our primary goal will be to walk you through the Android app development. Specifically, we will reference an app which I had created called Find My File. Okay. But to equip you guys with not just a basic coding skills, I'm sure you will know some coding, but also how applications are developed, what are the issues which comes. Sometimes we focus on something else, but the error, the root cause is somewhere else. So all those challenges we will present as a case study. All right. Good morning, everyone. Welcome to the case study of Find My File app. Over the next few hours, we are going to the journey through the entire creation process of this application, from the initial idea to the final published product. So how did we build it? Let's take a high level tour of the architecture. Think of it like a blueprint. We have four main sections that work together in this application. The first one is the Android app itself. There's the user interface and the on-device logic. We will see how we have used Jetpack Compose to build the UI and a view model to manage the state. The second is the local database. This is the workhouse of the application. We have used Google's recommended database library, Room, which stores the indexed content of all the files. This is what is making this application so fast. Third, our backend services, which are all powered by Firebase. This is where we handle user authentication, user account, security, subscription, run a secure backend code with cloud functions, and so on. And finally, our third party services like Razorpay for handling payments, which has been integrated into this slide. So, as mentioned earlier, our agenda for today is to go through the problem which we are trying to focus on or solve, how this application is solving that problem using AI, our key differentiator, how it is different from other search applications, and how did we actually build it. So, the problem slide. Let's start at the beginning with the problem in mind. I'm sure everyone in this room has experienced you have a smartphone, and then on the phone you have hundreds, thousands of files and of different formats. You have PDFs of contracts, you have photos, whiteboards, notes, screenshots, scanned receipts for expensive Word documents, and so on. And your digital life is actually on your phone, and searching through it becomes hell. So now, if you remember that a few months ago, for example, you saved a receipt from a client lunch that you mentioned coffee. That's what you remember, but you don't remember which date it was, where did you save it. And you open your phone's search bar and you type coffee and nothing comes. Because the phone's built-in search is, for the most part, looks for titles or file names, unless you meticulously name that file's content as client, lunch, coffee, receipt, etc. Your phone has no idea what is inside it. Your files are like locked boxes, and the information is right there, but it's not accessible unless you actually remember it. Now, this is where our solution comes in. This is the exact problem that we have been trying to solve. For example, um, finding files which are not meticulously organized. So it's not just under File Manager. It's an AI-powered search engine for your personal file, which runs on your local machine or your Android. So instead of just looking at file names, this application uses an on-device machine learning to read the content of your documents. And for the images, it performs an optical character recognition that parses the text from the images. It also parses text from PDFs and Word documents and Excel and so on. And it creates a private, powerful, and searchable index of all these contents. Now, after the content has been created, when you search for coffee, the app instantly shows you all the different single document that has this word. It transforms all this content from a simple storage into a personal, queryable knowledge base on which you can run filters. This app also allows you to run filters after converting all this content into queryable knowledge base. But simply having an idea isn't enough. We already have so much search option in Android and different phones. So how is this different? That's where we kept three core principles or pillars in focus to make sure it's different. First, it's very privacy focused. This is our most important feature. The AI processing of all text recognition happens securely on your device. Nothing goes outside of your device, not on internet, nowhere. No files are ever uploaded to a server. In this age, when users are rightly concerned about data privacy, this is critical trust factor, especially for sensitive business or your personal documents. The second important thing which you kept in mind was support multi-format. So this app is versatile. It looks through images, PDFs, Word documents, Excels, majority of text-heavy information, whatever is there. It can search through all of that. And third is user-controlled scope. So we will discuss this in detail later. But from user's perspective, this is powerful feature because it allows them to have control. The app does not demand and access your entire phone or all the folders. You can decide which folders the app is allowed to see and which it does not have access to. This means you're always in control of your data. So let's move to the actual application architecture. So if you see, it's a four-layer architecture for this application, detailing the technology, design pattern, and so on. The first layer, the user interface or the UI layer, this is the layer where the user sees and interacts with the application. It's built to be modern, responsive, and state driven. And we have used Jetpack Compose instead of XML. The second layer, the brain of the application, this layer contains the business logic and manages the application's state. It acts like a bridge between the UI and the data source. So between the UI layer and the next layer, which is the data layer, this is the middle layer. The data layer, which is actually the workhorse, and this is where all the data handling happens, from heavy background processing to the interaction or interacting with local and remote data sources as required. This is where it all happens. And then the last one, which is the integration part to and security and so on. For that, the backend services, we have used the cloud, which is Firebase cloud, and the third-party integration we have done is for payment is with Razorpay. So this layer provides the necessary cloud infrastructure for authentication, storage of data, secure payments, subscription tracking, and so on, without the need to manage our own server. So this is backend as a service which we have taken. Okay, moving on. So we have come to the UI layer, which is the topmost layer for this application. The This is where this is what the user sees and interacts with. For this, we chose Jetpack Compose. It's the modern toolkit from Google for building native Android use, and this is what you're expected to use going forward. So we'll go into more details later, but the key takeaway is that it allows us to build our UI faster and with lesser bugs than the older methods. The key files in this UI layer are search activity and the manage folder activities and the login activity. These three files are the core of this layer. With Compose, or we describe what the UI should look like for a given state rather than manually writing the steps to change the UI. This declarative approach drastically reduces the chance of errors where the UI and the app's internal state can become out of sync sometimes. Now, if you want to know the reason why we chose Jet Compose instead of just using the old method of XML, so in short, if I have to explain in simple terms, I'll give you an example, and then maybe you can understand. So imagine you want to build a small house with a red roof and a blue door. So in the old way, when you use XML, you have to give step-by-step instruction, like specific step-by-step instruction. If you have to give to a robot or to anyone, it'll be first you draw a blueprint, the XML file. You draw the square of the house, a triangle for the roof, and a rectangle for the door. This is the first step. Then you give commands using Java you tell the robot, find the triangle piece you drew. Now pick up a red color, paint the triangle red. Next, find a rectangle piece, pick up the blue color, paint the rectangle blue. And this is how you would do in XML. But in the new way, in the Jetpack Compose, when you're using, you just describe it and it gets done. For example, Jetpack Compose is like having a magic Lego box. You don't give step by step instruction. You just describe the final house you want or the output you want, and the code does it. So you write a single magic instruction in your code saying, "Build me a house where the roof's color is red and the door's color is blue," and that's it. The magic box automatically creates as you have described. Now, the debugging process is easier. The change process or change management in this Jetpack Compose becomes easier because now, if you have to change the color of the door to green, you don't write a new whole command of a new house with red roof and or blue roof and a new door color how you would have done in XML. Here, you would just change the command. Build me a house where the roof's color is red and the door's color is green. That's it. And it's less work, it's fewer mistakes, it automatically updates, and it faster updates. That's why you use Jet Compose. Now, we'll move on to the next layer. Okay. So now we have reached the next slide, which is the logic layer, which is our app's brain. So this is where the application's intelligence lives. We have used the model view model architecture. It's called MVVM, and this is very industry standard. So you guys should research more into this if you want to know more. We'll also try to cover it later. This is crucial because it separates the UI from the business logic. The main view model.kt file, stands for Kotlin, is the heart of our application. That file is the heart of our application. It holds the application state, like what is the current search query, the results, the outputs, as and all of this as observable state flow objects. The UI layer simply subscribes to these objects and updates itself based on data changes or state change of these objects. This makes the code clean, easy to test, as we don't have to go to the UI layer to run and verify the view model's logic. So you can do it using Android Studio features without even running the whole UI or the whole application. Now, the main view model file, which I talked about, it has three main responsibilities. One is to manage the state, where it holds all the important information that the UI needs to display, such as current search query, list of search results, whether a process is loading, what is the user's current subscription status, trial, subscribed, expired, deleted, etc. It exposes these kind of data using state flow to the UI, which allows the UI to update automatically whenever the data changes. Now, the second important thing is responsibility of this layer is the business logic, where it contains the function that the UI calls when the user does something. For example, when the user types in the search bar, the UI will call the on search query changed. This is a function which is defined in this file. When they tap the search button, when they click the search button, and it calls the perform search and rank function later based on that as a continuity, and so on. So all the functions are defined based on buttons and activities which can happen in the UI layer in this particular business logic in the main view model.kt file. Now the third one, the third logic or the responsibility which it takes care of is the data coordination. So it acts as a central coordinator for all data related tasks, and it's the only part of the application that talks directly to the data sources. The backend services doesn't talk directly to data sources. The UI doesn't. They all have to route through this layer to talk to the data services. So it tells the work manager to start heavy background task of indexing files. It listens to real-time updates from the backend services like Firebase and Firestore to check user subscription status. It saves and retrieves the list of searchable outputs or folders from shared preferences. It will be responsible for querying the local room database to get search result and show it on output in the UI layer. So that is why this particular layer is the brain of our application. Now we'll move on to the next. Okay. So moving on to the next layer, which is the data layer, which is the workhorse or the heavy lifting layer. So like the previous layer was your brain, this is your strength, or this is where the muscle of the application is. So this layer is actually responsible for doing all the heavy lifting, and we divided into dedicated classes following the single responsibility principle. Like all different heavy lifting activity will be considered as one single dedicated class. So for example, the text recognition helper, it will handle all interaction with the ML kit, the machine learning kit. The file indexer worker, which is one of the file again, is a crucial component that manages the intensive task of scanning the selected folders or the folders which you have allowed the application to access in a guaranteed background process. So this will prevent the UI from freezing. Otherwise, if this activity happens in the main thread, it will take a lot of CPU and RAM, and your application will crash. So that is why the file indexer worker as a separate background work class becomes important. So a critical performance decision we will explore later. And similarly, a shared preference is used for the simple task of remembering which folders the user has given us permission to access. So every time you launch the application doesn't need to remember, or you don't need to add the folders once again. The first time that you add these folders, that's more than enough. The application remembers it. So that is why this particular folder is crucial for the success. Now, the text recognition helper, what it does is it breaks down image and files as input in form of bitmap if it is an image, and then using the MLKit, it does uses a MLKit library to scan the image and identify any text within it, then processes and converts this phone uh, the text in that image into plain text, which can be used later by other helper classes. Now, after the AI model analyzes the image, this particular text recognition helper, it returns a simple string of text that it has found, which can then be used by the other file like file index worker for processing. So by using AI through this helper class, we have segregated the workload separate from the other classes and the UI layer. So only when required, we will be initiating the AI logic. Now, similarly, if you look at what are the responsibilities of file indexer worker, it first of all it runs independently. So it is built actually using Android's work manager, which means it runs in a separate OS managed background process, which is key to solving process issues. Otherwise, we will see that logs, like frames, are being skipped if you do not use a separate OS managed background process, because your application will then start pulling lot of CPU and RAM. Then it receives a folder to scan. This is one of its main activity, and the which folder to scan is actually told to it by the main view model, which is the in the logic layer. Then it processes all different file types using OCR for images, which is text recognition helper. PDF files, it uses iText library to parse the text. For doc files, it uses Apache POI library to extract the content. And then it prepares these data which it has extracted into indexable text. So after extracting the text from a file, the worker's job is to save that text along with the file's name and path into the local room database. So by offloading all this heavy lifting to the file indexer worker, we ensure the user can continue to use the app smoothly while their documents are being indexed in the background. So it's the core component that enables this app's powerful search feature without sacrificing the performance. Let's move on to the backend services. Okay, so we have reached the last of the architecture layer, which is the backend services or the cloud or backend as a services. Now, this layer is where the management of infrastructure, security, authentications of user, third-party integration, and so on actually happens. Excuse me. So this layer provides the necessary cloud infrastructure for our user and authentication, data storage, and secure payments without need to manage our own server. So the platform we have used is Firebase and Razorpay, and we chose backend as a service because scalability is there, elasticity is there, rapid deployment can be done. We don't have to worry about management and so on. The key components like Firebase authentication, Firebase Firestore, and cloud functions and SDK integration. So the authentication, which happens, this function handles all user sign up and sign in flows securely, including Google sign in or phone and OTP sign in. It also manages sessions and provides unique UID, which is used by the system. The Firestore is a real-time NoSQL database, and it acts as the source of truth for each user's subscription status, like trial has end date or trial end date, expiry date, subscription date, subscription expiry date, and so on. Now, the Firebase Cloud Functions, this is our secure serverless backend. The verify razor payment function, which we have created, it runs on Google's servers, and its only job is to securely verify a payment with Razorpay server and then validate, update the user's record in the Firestore. So this is the core of our secure payment mode. And the last third-party integration we have done is with Razorpay SDK. So this is the client-side library that provides the payment UI and handles the transaction process within the application.
So one thing, uh, you mentioned that it's only store mobile number as well as Gmail. Right?
Or
However, when I and I downloaded that application and I saw in the description it's a mention location, contact details, also location, and the payment financial is also getting is
to answer your question, whether the application retains location, payment, and contact details, location details, no. So how it works in our application? Our app does not have any code that requests access or stores users GPS or network location. We haven't added any kind of code in Android manifest.xml. So Android.manifest is the file where you define what kind of accesses you need within Android or using Android for the application. So we haven't defined it there. So technically, it doesn't have a capability. Now, location might be accessed is actually accessed by Razorpay SDK, which is a third party. It doesn't that information doesn't flow to the app. So Razorpay SDK will collect the approximate location for fraud detection system. So all uh, payment gateway do it. So because the Razorpay library is part of our application, we have to click that option that yes, approximate location is um, included as one of the data points, but it's not directly with our application. It's actually with Razorpay. Now for payment details, no. Critical security point of our application is that we don't take the payment detail. Now again, Razorpay tracks your payment detail securely, and it's their job. So the entire payment process is handled by Razorpay SDK, which opens its own trusted web-based interface when you click for payment. That information doesn't come to us. So our application never sees, handles, or stores any sensitive payment information like your credit card number, CVV, UPI ID, or bank account, anything. But when the payment is successful, the only piece of information that we receive is a temporary non-sensitive payment ID generated by Razorpay. Now, this ID is immediately sent to our secure Firebase cloud function for one-time verification with Razorpay's server. And once the backend function does not our backend function, after verifying, does not store this payment ID. Its only purpose is to confirm the payment was real based on this ID which was provided by Razorpay. Now, the only thing we store in our database is the final subscription expiry date. So when the payment was done, from there we add 1 year and we make a subscription expiry date. That's the only piece of information we update or store. Contact details, does our app retain it? Yes, but only your email ID or phone number, whichever you have used to log in. That's it. Now, when you sign in the Google button, the Firebase authentication provides us with the email address which you have used and our login activity code that saves this email address into the document, the Firestore database, as your document, which we use for tracking and updating subscription and so on. The phone number, even though the UI has a field for a phone number for OTP login, our we don't use it to store phone number. So our Firebase authentication handles your verification process, but we do not store the number in your user profile. So the Razorpay SDK may also ask for your phone number during checkout, but that's their part of application or system. It doesn't. We are not able to see it. Our application has no information about it. So in summary, the only piece of personal contact information that my app will store in its database is the user's email address, which is used to identify your account. All other sensitive information is either not collected or handled entirely by a secure third-party services. In this case, it is Razorpay. Okay, so with this, we are at the end of our today's session. And to summarize, what we have done is we have looked at the problem, looked at the usability of this application, what was the vision behind it, the key differentiator of principles, which are privacy, multi-format support, user control, which we provide to the users. And then we looked at the four-layer architecture, the UI layer, the logic layer, which is the brain, data layer, which is the workhorse, and the backend services layer, or the backend as a services, which takes care of your security infrastructure and so on. And next session, we will look at the real world debugging and problem solving that we have used in this application. The library issues, the failures which were caused by deprecated libraries, how we overcame it, and then the decisions we uh, took to decide on which ML kit we are going to use, cache issues, non code issues, which how to identify it, how to fix it, and so on. So again, thank you guys for joining, and hopefully in the next session we'll see you guys again, and we will look at how we can improve your knowledge through these sessions. Thank you.